Let's see. I don't know if I see the. Yeah. So we are. The room is filling up. Yeah, I think we can start. So, welcome everyone to this webinar in the Iliad Hackathon. It's called Best Practices and Standards for the Hackathon, and the purpose is to help you with some instructions and some ideas on standards and best practices to get you started on a good path in the hackathon. Today we have several speakers, experts from the Iliad community, and I will show you the agenda. I will start with that. My name is Bente Liljaby. I am the innovation manager in Iliad, and I am the owner of a company called BLB, dedicated to research and consultancy related to Earth observations. And now, let me see. I will start by sharing my screen so we can see what the program looks like. Like this. So first, we will provide you with a quick overview of Iliad, the project. And then we will learn about the standards and best practices in digital twins of the ocean and how to find them by Sigmund Kluckner. And we move on to best practices for data platforms by Valeria Piziol. And further on towards standardization of citizen science-based jellyfish observations data by Dori Edelist. And last but not least, best practices in Iliad modeling. And we will encourage you, of course, to use the chat for questions and comments. And after each of the presentations, we have a short window for a Q&A, but if times allow, we also plan to have discussions at the end of all of the presentations. So I dive directly into the presentations of Iliad. So we start with what is a digital twin. What do we mean by digital twin? It's about what now, what next, and what if. So it's a complex way of seeing, or a time varying way of seeing, a digital twin of the ocean. So a digital presentation of a reality. There are some digital twin definitions. You see here one from ISO, which is more generic, but we also have the ditto, so the digital twin of the oceans activity as part of the UN Ocean Science Decade, and that is referring to more, is giving more relevant definition, including the two-way connection with observations and the real geophysical reality, and the possibility to refine the twin during over the time, and also manipulating, as I said, what if scenarios. It's important to note that it's not only what we want to look at for the future in the twin, it's also about including more information about what happened in the past. As you know, there are a lot of data that is not yet digitized, and as we get that accessible, we want that also to be included in the twin. And we say, and this is specifically what we address in Iliad, I would say, what else? So what is the contextual data around your digital twin of the ocean? It could be a physical installation, it could be statistics, economics around your activity in the ocean. So a little bit about digital twin definition. So Iliad in a seashell is about enabling an ecosystem of interoperable digital twins and is based on connecting existing ocean data infrastructures and also enhancing it with additional observations through sensors, for instance, and citizen science. We want to make it accessible through a marketplace. So we have established the Iliad marketplace where you can find both the digital twins themselves, but also its individual components. And we will come back to why this is a good thing. And of course, we are contributing to solve some of the challenges that we are address in society. We really embrace the fact that the ocean is complex and vast. So we are looking at the different components, the geophysical, the biological, and the numerous interactions between them and human activity. We are a part of a European, not only European, but a European ecosystem with several digital twins and other resources. But I also want to make you aware that we are not only addressing Europe, but we are also in Africa and in the Middle East. The point is that we need to align all of these resources, both on the technical perspective and also on a human and policy perspective. We are developing digital twins, plural, and we cover many thematic areas. You see some of them here. We have divided it currently in 12 thematic areas, and there are overlaps between them, of course, but the point is that we are covering different thematic areas and geolocations. Here is a very quick overview of the Iliad architecture. We don't have time to go into that, but you see the data source to the left. You prepare the data, you process the data, and then you present it in visualization or the format the end user will need to have it on. We are, as I said, the word to note in this figure is we are actually combining numerous types of data. Some of the data is open, some is commercial and restricted for other reasons. They come from all types of sensors, from satellites and citizen science observations. These data are then being used for the different thematic twins. And I will like to highlight here, I don't know if it's easy for you to see it, but they are all built on the same architecture form. And in order to facilitate interoperability, not only within the twin itself with the different components, but also between the thematic twins and the geolocated twins. We are connecting very much to EDITOS, which is the European core infrastructure for a digital twin. And another component that we have in Iliad is what we call the innovation booster or the business activities. It contains the Iliad Academy, business, different business activities, policy, we address policy, and a marketplace. And in short, this is a Horizon 2020 project. It's funded under the Green Deal. It's rather big, I would say, or close to 19 million euros in total, and we are 56 partners. With that, I will end my introduction to Iliad. And if you have questions about it and more detail, you can find, of course, on the website, and you can ask in the chat or at the end here. Any comments? Any questions? I think Arne, Jørgen, I see you. Probably not muted.
Yes, let's see.
Yeah, I hear you.
Yeah, I think I guess the main point is that we will have a number of webinars coming up to prepare the support of the hackathon. So this is the introduction of the standards and best practices, and we will go in more details in the forthcoming webinars. but it's important to have this broader perspective because we are also interacting and impacting the various standards organizations, as we will hear about.
Yeah. So the point by giving this very quick overview is to show that there are many incidents where we will need best practices and standards to make it all interoperable. So let's dive into it then, standards and best practices in digital twin of the ocean and how to find them. And that's Siggy that will from IEEE that will give this presentation. And but I will share my screen again.
Thank you. And just confirming, am I right side up to you in the video?
Yes, you are.
Okay.
Yes.
And I don't have to bend over.
No, you don't.
While giving my presentation.
It's all good. It's all good, Siggy.
All right.
Let me see. There you are.
All right. Thank you. All right. Well, welcome everybody. Also, thank you, Bente, for the introduction and the team to organizing this. I'll shortly talk about standards and best practices in digital twins, especially digital twins of the ocean, and also a little bit of signposting on where to find possibly fitting best practices and standards for the hackathon. Yes, I did this. This whole thing was done with the team of the IEEE in the Iliad project. Jay Pillman and Pauline Simpson are on the call as well. I'm saying this because I have to leave shortly after, so if there are any questions coming up later, they can also hopefully stay and respond. Okay, so a quick introduction. What are best practices and standards? If you click, you'll see the definition or what we call how we define a best practice. It evolves from individually developed methods, so it's more of a grassroots development, and it transitions to be a best practice when it is helpful for others. And it turns out that this practice or method is the best for similar approaches. It can become an endorsed practice or possibly also evolve into a standard. In comparison, a standard is a documented set of guidelines, specifications, or criteria that are created through a defined process. So they are defined, and that process is under a standards organization that observes and supervises that process. That most well known that everybody probably has heard is the ISO. In a geographical sphere, we have the OGC, IEEE from the electrotechnical engineering, and so on. The W3C, for example, also from the World Wide Web Foundation. And most standards are likely to build on related best practices. This is mostly because people who work on standards have their own practices and bring that into a standard and agree on that by consensus. All right, next click. Basically, it will both standards and best practices ensure consistency and uniformity in how things are done or produced. And I think this is very important. It should help us get from a starting point to an end point in a more efficient and also standardized way, right? So that it's much more comparable. And they give a common language instead of rules that everybody can follow, and then also everybody can understand on how things happened or what went into these kind of developments. All right, next slide. So why would we use best practices? Partly these also apply to standards, but of course best practices are efficient use of time because somebody has already done it and has shown that it works. We have collaborative opportunities because they're a grassroots effort, so people come together and work together on these. We have, especially for digital twins and for other systems, we have the interoperability that is improved because if people build on the same bases, you could think of PowerPlex, for example, right? That's just PowerPlex are standards, but at some point they were best practices within the country. We have in systems, we have data comparability and collectability. Of course, if best practices are putting in data, then that also means that the trust is greater because it is a community effort. It can help with the regulatory approval as we'll do with standards. And of course, we also can expect higher funding successes for projects because they are also working together as a community, and then you go from there, and funders like to see that. All right. Now, switching over to standards, why would we use standards for digital twins? And this also applies partly from the best practice, and you'll see that these are sometimes used interchangeably. How they come about are the biggest difference. So standards, what we could use digital twin standards for are from a technical side, so the data collection and the storage. Partly these standards are already there. Partly they need to be shuffled a little bit for digital twins versus other digital innovations and tools and systems. We can create standards for reference frameworks, for system architectures. Then, of course, this was inside the digital twin. We can also do that on a connectivity and interoperability basis, so that if we wanted to combine two twins, how do they exchange the data? What is the interconnectivity? What is the portability of the algorithms, of the code, of the models that are used in digital twins? Can they be taken from one thing and put into another and still work? We have data exchange and the reuse of that. So what are the inputs and outputs? Are they defined? If they are defined, are they standardized? And then, of course, we also have the semantic interoperability, which includes ontologies, taxonomies, and all the likes, to make sure that what comes out of digital twin is also understood by somebody else or some other twins. And then lastly, we also have procedural standards, so we can look at engineering processes in the sense of how is a digital twin and then of course, validation digital twins. What comes out of it, is this even valid? Is this close enough to reality, and so on. Okay, next slide. How can standards and best practices help? So especially now in the hackathon and in the development of digital systems, you have to look at a lot of different things, right? So you have methods on how to build things. You have the data that goes into a digital twin. You have the architecture on how the data flows. You have, for example, citizen science, which we will hear later, on how do we get that data from possibly other ways of other sources, let's put it that way. The modeling on what is happening inside the computing will be a part, and we'll hear about this later as well. And I mentioned already the semantics. So for example, the ontologies and that we can use or reuse that go into the broader aspects of interoperability as well. All right, so a few examples, and I think I already mentioned most of them in the next slide, are a few organizations and platforms that are very related to the digital twins of the ocean and digital twins of the Earth in general. You have the ISO, the International Standards Organization, which is, I think, the most well-known and also biggest organization in that sense. Arne, I'm sure can correct me if I'm wrong there. We have IEEE, of course. I would be not a good team member if I didn't mention my organization there. We have OGC that looks at the geographical standards. We have the W3C, the World Wide Web consortium that looks at all the interconnectivity on the web. Yes. And of course, there are many other international and national standards organizations. There are also consortia. If you think about the USB consortium, for example, they have set out that standard, and I think slowly a lot of consortia are also then eventually consortia outputs are taken into the standards organizations mentioned above. On the next slide, we have a few example standards that are related to digital twins of the ocean. So I mentioned the ISO. ISO has a working group on digital twins within the IoT and digital twins section. Bente, you mentioned the concepts and terminology. You mentioned the definition that's coming out of that 3173. We have other use cases that are on digital twins. ISO currently looks more on the manufacturing and production digital twins, but of course that can expand, and we're working towards expanding this to environmental digital twins as well. We have the AI and big data use cases or standards that are published. We have the OGC. One example, of course, is the NetCDF. I'm not quite there yet. We have the Digital Twin Association that is doing some standardization work. But then also, just for keeping that in mind, is there are some basic things in digital twins that are also standardized. For example, the RESTful APIs or the HTTP that are heavily in use, but of course, not to forget. And in the Iliad project, we have in the development the ocean information model as a semantic example. And of course, I'll talk about this in a minute. The recommended practice for the development of digital twins of the Earth that we're working on in IEEE. All right, the next thing is where to find practices. Good, better, best, endorsed, however mature they are. We'll have OBPS here, and Pauline can say a lot more about this than I can. We have the Iliad Marketplace, where we'll also have practices, and then also additionally, as Bente mentioned, components and models, anything that has to do with the digital twin of the ocean of Iliad, or the digital twins of the ocean, you might be able to find there and reuse. We have ICES, we have the Ocean Info Hub from ODIS, and we have the European Citizen Science Association, just as a few other examples on where to find practices. As a next item, we have the Ocean Best Practices System, which is an international project. I think that's the most important part. It's co-sponsored by IOD and Goose, and we want to have agreed and broadly adopted methods across oceans research, operations, and applications. And of course, that is also part where digital twins of the ocean can come in. So anything that's method on the digital twin of the ocean can come in there, and we also aim to do so. Next slide. That's 2 clicks, please. Two things of call to actions I want to say. One thing especially for the hackathon, we are here to support. So if you have questions about standards practices, please get in touch with us. We're happy to help, happy to find standards or best practices for the project, provide input on the best ways to use those within the project, or brainstorm ways that we can collaborate. So go in both directions. Which is also the next slide that you're in charge too. So you coming out of the hackathon, all the teams that are working on something can contribute to standards efforts, for example, at IEEE, which is, I happen to run these, so that's obviously easy for me to say. We have, as you evolve the project, you can contribute the experiences in the practices, so you can contribute and submit best practices to the OBPS or otherwise. And of course, you want feedback. So if you're using practices, you can feedback to the creators, what worked, what didn't work, to the catalogs. So OBPS will be happy to hear from you. And of course, also the Iliad Marketplace, if there's anything that doesn't work or works really well, we like to hear from you. And then lastly, 2 things that I mentioned before. I have standardizations running on IEEE. First of all was a study group on digital twins of the Earth, which just ended. We proposed a standards working group, which is now called P3501. And that was submitted to the NESCOM, which is the new standards committee, and the decision is expected tomorrow. So we'll see, and after that, we should be able to help to start with the working group. You're all more than welcome to join and contribute. And if you want to do that, you can email me, and you see my email address there. Best would be probably sigmund.kluckner@IEEE.org. And lastly, we have the Industry Connections Group, which is also running through the Standards Association. However, it's it should provide a low barrier entrance to standardization. We're convening a group of interested people in digital twins of the Earth, and the activities will much be around developing white papers on digital twins of the Earth, also broader than only the ocean, and later on also provide work, potentially start working groups on other aspects of digital twins of the Earth. in the standardization work. And if you want to join that, please use that link or in the QR code. And then we planned the kickoff for June 26th, so there's still time to sign up and join. And that's it from my side. Thank you. And I'll be here for a few minutes for questions, and then I have to run, unfortunately.
Thank you very much, Siggy. A lot of resources and information in that presentation, and just a reminder that these slides will be made available for you, and we will also we are also planning a resources page connected to the hackathon on the Iliad webpage, so that you will have multiple ways of revisiting all this information. But now, do you have any questions for Siggy? Shoot. Let's see, you raise your hand, or I will see in the comment here. Yeah, so Jay, do you want to ask it?
Yes, Bente, thank you. Siggy, you mentioned industry in your last slides. What types of industry would be interested in digital twins of the Earth or digital twins of the ocean?
Good question. Yeah, so industry in the sense, more of those organizations who are building digital twins of the Earth already. So there is, for example, NVIDIA, who obviously is very interested with their Earth 2 project. We have Microsoft with the planetary computing, who could potentially be interested in participating in the digital twin standardization efforts. I have Google, for example, that also have activities towards the digital twin of the Earth. However, I do not know the name right now. And then there are a few quite smaller organizations, and especially startups also, that work on digital twins of the Earth. So for example, here in Austria, where I'm based, we have blackshark.ai, and they are doing a lot of let's call them geographical digital twins, also towards cities and all these kind of subsystems of digital twins.
Yeah, and I also know Capgemini actually has been showing an interest in this hackathon, and they have a lot of digital twin activities going on, just as another industry or business.
Thanks.
That is interested.
Yeah, great.
So Arne Jørgen, you are raising your hand. The floor is yours.
Yeah, thank you. I also put in the chat because I noticed that for this IEEE Industrial Connection, the title was Digital Twin of the Earth in singular, while I think it rather should be digital twins in plural, as we have also experienced in the Iliad project, because there will be many twins and they need to interoperate. So the plural would be important. Because, I mean, we also talk about European digital twin of the ocean in singular, and that we have found to be misleading, because some people would then think that there is one big twin, that's the only we have together, and it grows and grows, which is not the most scalable approach and most efficient approach. So it would be good to take that problem away in the beginning, and not in the title.
Yes.
Yeah.
Thank you. I fully agree.
Yeah. Thank you very much. We are moving on. Valeria, you are going to talk about best practices on data platforms. So Valeria, the floor is yours. Give a short introduction to who you are also first, if you don't mind.
All right, thank you. I will start sharing my screen just to check if everything works. And you should see me now in presentation mode.
Yes.
Okay, so I am a project manager in ETT. We are an Italian-based ICT company, and one of our core businesses in the research and development department is the data management system and decision support systems. But today, as you can see from my slides, I wanted to highlight the link between one of the products that we take care of, that we curate, which is IMANET, and more specifically imminent physics, which I guess many of you already know, but I will just give a quick overview, and the ocean best practices. So which is the link, which is what are the actions that are happening right now in the best practices domain, and what are the next steps. So just to give you an overview, EMITNet stands for European Marine Observation and Data Network. As I was saying, I guess that many of you already know it and already use it for work or for academic purposes. And EMITNet is basically a public European marine data service. It's open to all, it's free, and it's open access. It covers 7 thematic domains and more than 100 parameters. It also covers in situ, in water data from the marine environment, but also human activities at sea. So that's also something to keep in mind when we talk about the data that come from citizen science activities, but also industrial activities at sea. The data sets that are present in EMITNet are sourced and aggregated from 100 of diverse data providers. And what's the main point is that those data are standardized and harmonized to European and international standards. So that's when best practices also come in handy. The data are integrated into high-resolution data layers that you can that the user can interrogate based on their needs. And another important thing is that all the data products presented in EMITNet are under the data policy Creative Commons, which means that can be used, can be shared just by citing the source. So another important thing and another important focus that the EMITNet network is really, really stressing on is the use of metadata, because as we know, metadata are basically the standards that we use to describe data using, for example, international, so the ISO standards. EMITNet does not only stop at the European geographical area, but also includes datasets from all over the world. The 7 thematic domains are bathymetry, human activities, physics, geology, seabed habitats, chemistry, and biology. And as I was saying, all these parameters are managed by one central metadata catalog, which allows to enhance the data search and the discovery, hopefully making our lives easier as we go on integrating data. Going in depth very quickly in EMITNet Physics, which is the service that ETT is a coordinator for, and about the latest key achievements in the portal. The latest achievements that we've had is to reach the fairness of the data and the products. So that's also best practice. That's also mandatory. But that is something that we are still working on, and that we are still asking all the data providers to work on and to be ready on. What EMITNet Physics integrates is near real-time and delayed mode data on ocean physics, and that builds on already existing marine data infrastructures and programs, all under the common umbrella of common standards and tools. The parameters that are presented by EMITNet Physics are many, and they go from the basic ones such as temperature, salinity, but also at the moment something that the European programs are really focusing on is, for example, the underwater noise, which is something that we still have to collect data on in order to allow the policy making process a little bit easier. And something that is highlighted in immanent physics is the continuous data flow, decentralization of the service, and the capacity building of the service itself. So this is just an overview of what you can find not only in immanent physics, but in the whole immanent network, which is a description of the products and the parameters. And then a map viewer with layers that can be turned on and off in order to see the aggregated data based on the specific needs of the person that is looking for data. Yeah, so as you can see, this goes from the overview of the map to the detail of the single data set. So the ingestion process in IMNet is organized into phases. So this is basically a process that allows not only the presentation of data as is, but also brings the data to become harmonized and validated collection. As you can see in the workflow presented in the slide, when there is a new source, which is basically connected by personal connections as the ones that we are doing today in the workshop, there is a first checkup on the data set, which is about basically the data format, the license protocol, and the license of the presentation of the data. There is a minimum metadata layer that is needed, so at least some metadata must be present. The first layer of ingestion happens, which is the which is when the data set is made available in EMODnet and can already be seen. So that's the first layer. And in the meantime, there are some automatic and standardized quality control and quality flex checks, which require the enrichment of the metadata in order to become an official collection. So this is something that is really linked to the concept of operational oceanography, because the variables that are needed to present the data not only in IMODnet physics but in the whole network come from what the state of the art about metadata and variables requires. So as I've said before, the data get a automatic quality controls, but all the ingestion and physics action to streamline data flows from new identified operators and stations towards one of the major pathways that IMODnet uses to connect sources are based on these variables that, for example, you can see in the slide that are coming from the Goose guidelines. These guidelines come from a bigger network, which is called the Marine In Situ Collaboration and Coordination Network, which includes not only entities coming from IMODnet like physics, chemistry, and also ingestion, but also from different other entities that operate either on European and international level, such as Copernicus, Eurogoose, DataCNet. So everything that comes from this injection action is basically aimed towards having one entry point to facilitate data flows from new identified operations to one specific portal to reach the data. I'm not going in detail on this, but I'm just going to present to you what IMODnet physics considers as data. So in three different layers, the data can be defined as simple data, which is basically a series of values sampled by an in situ platform, a data collection, which is a grouping of similar in situ data, and a product, which is basically a higher level of presentation of the data because it is the outcome of a reprocessing method. So in the IMODnet network, these three kinds of layers can be found and can be achieved. The results of the quality controls procedure are not considered the product, but those are basically, as I said before, just a qualified data set or a qualified data collection. As we were saying, one of the best practices that we have to put together is the use of vocabularies. For example, a new set of vocabularies, the P33 dedicated to physics, has been implemented in the past few months. And this includes terms that are used to group parameters into broader categories to be used to improve the data discovery and the data aggregation at products level. So basically, for example, all the data connected to salinity or all the data connected to another physic quality can be brought together by a new set of vocabulary, which is identified with the code P33. One of the tools that we use most is AirDAP, which I believe many of you already know and use, which is an open source dataset which allows us to link the datasets with the metadata and to present them in the form that I've been showing earlier. So that can be presented in the EMODnet platform, but also can be presented in many other different visible ways, as the map that is shown in the picture. And one thing that we are stressing is the presentation of the dataset and of the metadata in the system. This is basically a simple representation of what you can see when you look for a dataset in EMODnet. So there are the most basic data and the basic information about the dataset. But what has been included lately, and the thing that we are stressing the most about when we participate in workshop and when we participate also in other European-based projects, is the link between metadata and best practices. Because the metadata, as we know, express the type of info that we have in the dataset. For example, we have the information that answers to the question where the data has been collected, when it has been collected, but the link with the best practices is how the data has been collected, because the methodology, which also allows us to calibrate better and in less time the instruments that we use to get data, are linked to the methodology and to the best practices. So nowadays, in many datasets presented in EMODnet and with a growing number, there is a DOI which is connected to the dataset. As you can see, for example, this is linked to the Argo floats data and metadata from the Global Data Assembly Center, and the best practices that are connected to that kind of data, that kind of sensor, that kind of methodology. So this is something that we are really pushing towards, to even better link the use of metadata to the knowledge and the better use of the best practices. So thank you for your attention. I think I got all my 13 minutes, but I hope that there's still a little bit of more time for the questions.
Thank you very much, Valeria. We have, I saw that Jay had a question and got it answered immediately. So we move on to Arne. Do you have a legacy hand or do you have a new question?
This was a legacy hand,
Yeah.
so it wasn't automatically down. Thank you.
I think I saw another question. Dory, did you have a question also?
Yes. Is there since I come from citizen science, which is the next topic we're going to have, I was wondering whether you have a list of organizations contributing citizen science-based data to EMODnet.
Yes, we do a list of organizations and also a list of projects that involve also citizen science activities. You can find those in the website of it, and many other websites related to the single projects also bring the link to the EMODnet network.
Excellent. So Valeria, I have a very quick question also concerning, now we are talking about this Iliad Hackathon. And we hope that we will be collecting some new data through sensors. Will that be possible then to upload directly to the
Yes.
EMODnet? Yes.
Yes, it is possible, and it is possible through the EMODnet ingestion service.
Yeah.
There is a dedicated website which has all the pathway and all the information that you need to manually and personally upload your new data.
Yeah. Excellent. That sounds like an interesting experiment that we can include. Any other quick questions before we move on? I see we are behind the schedule a little bit. So I hope that you are. We will. Yeah, Jay, you are raising your hand again.
Yeah,
Jay, yeah.
Valeria, a question for you. If I'm in citizen science and I want to contribute my data, how does the quality control of that data addressed in EMODnet?
Well, the citizen science data do have a sort of quality control, but it's not as strict as the data that end in physics, because obviously, as we all know, in citizen science, there cannot be a quality control also in situ, because people might not be used to do that kind of thing. So the control of data coming from citizen science is slightly different, and many of those data do not end up in the specific, let's say, bathymetry, chemistry, or physics parameters.
Yeah, I think we will come back to that. May I just remind you to to mute yourself while you are not speaking. Easy to forget. Now we are moving on. Thank you so much, Valeria. Thank you so much. Very useful. Towards standardization of citizen science-based jellyfish observation data is the next topic, and it's Dori Edelist from the University of Haifa who is going to introduce us to this topic and introduce us to himself first. Dori, thank you. The floor is yours.
Thank you, Bente. So hello, everyone. My name is Dori Edelist, and I'm a marine ecologist from the University of Haifa. And as ecologists, we like to say that this is the hardest of all professions, although physicists usually get more applause. And the reason is because in the ocean, everything is connected to everything. And even if you have good sensors, sometimes you're only sampling a part of the ocean, and looking at an entire ecosystem on the multitude of connections there is an immense task. Also geographically, which is why citizen science is so good in stepping in where things cannot be seen from space. Ergo, jellyfish. We're going to speak now. I'm going to share my screen quickly, and we have about, I think, half of the time that I wanted to spend on this. Presentation mode, there we go. Okay, so just a second. Yeah. Okay, so jellyfish are magnificent, ancient organisms, and studying them is always a lot of fun and very challenging, especially geographically. And that's why one of the main reasons that we use citizen science is that we need a lot of eyes in the water, also underwater, and we need a lot of them because visibility might harm cameras, and acoustics are not yet perfect, and seeing them from a space is not yet working. And yes, we have Starlink and we have amazing coverage, but even with AI, observing jellyfish from afar is still not there, and it's not, for sure not cost benefit. The cost benefit is not there for expensive projects. So in order to gain access, we tap the public, which is great because it's a win-win situation. We look at these amazing organisms. There's one of them eating another. That's actually happening in the Israeli Sea right now as we're speaking. We're expecting a swarm incoming this week of jellyfish in Israel. And people are really interested in that because they don't want to be stung, and because jellyfish cause a lot of other challenges to desalination and power plants, for example. So we have an interest, a vested interest. And in order to resolve the quality of citizen science data that we were discussing before, standards need to be set and met. For this hackathon, we imagined 3 different themes that were created basically when we asked a network of 23 experts from 12 different organizations that are all working on jellyfish monitoring. We created this network within Iliad, and then we asked them what are the main challenges, and data quality was high in them, and standardization in order to bring forward the interoperability was also high. So these are the organizations on your right-hand side. This is how they're spread out across Southern European seas. And our what-if scenario here is going to be, what if we could all speak the same language and have all data interoperable and standardized? So that's the main theme of my talk today. Maybe we'll just sprinkle on a bit of the other hackathon goals later on. So we have these organizations, we call them JOIs, Jellyfish Observation Initiatives, and they're spread out. All of them work with citizen science. They have different motivations. They have different methods. Sometimes they have never spoken to each other before to standardize the data, other than an Italian and a Spanish organizations working a bit together. Then we have met everyone for the same time and for the first time together, and sort of gotten some of the data sets that they shared with us. So we have 4 data sets from these 4 places. We're looking mainly in the hackathon probably to utilize some of the methods that I'll show you that we use to standardize and set best practices. If we look at the different organizations, really we can see very large differences in how they maintain and manage their data, how they get the data from the people, and in a nutshell, a response to how our main way of dealing with data quality is through training and setting goal user status to trained users. So we have people that we know we can trust, and then use them to verify and validate other data. Maybe double weight their data or in the standardization process. But in order to do that, and in order to get the data into IMODNet, as Valeria showed before, we need standards. And so that's our number one challenge here is standardization. We're looking at several different organizations, such as the Ocean Biodiversity Information Systems and GBIF and Integrated Ocean Observation Systems. All of them set vocabularies and work according to, we mentioned metadata before, Dublin Core for metadata and Darwin Core for the data itself. So the terms that we use are in line with these standards. And here are some of the terms. First, we start with OBIS 8 required terms. If you wonder why there's scientific name and also scientific name ID, is because when we're talking about biology, there has to be reference to a standardized website like the AFIA ID, either in GB or in several of the large repositories. I'm sure in IMODNet also they have the standardized names, and all of these fields have to be filled. We also work on an ontology from a different perspective with SemFlow, which is a software created by Ramani to co-create this platform. So other than the must-have fields that we showed here, these must be there. And if we take, for example, we took the Israeli data and put it through this, and now end up with a standardized database that is set as it goes to the ocean information model of Iliad to also be transferred to IMODNet. So thank you, Valeria, for just putting it up there, and for the question, Jay. Now, these elements, we also consider them as vital because we must know for excess validation, for example, if you have photos of the animal that you saw, we can use it through AI or machine learning for extra validation. If you look at the organism quantities, that is where we had the most problem with, because apparently looking at a swarm of jellyfish and saying how dense it is very, very challenging, even for the expert and even for the scientist in the field, whether we use density or abundance. And we found with our network that ranked abundance works the best for everyone. And it was not only the lowest common denominator, but it works differently for large jellyfish and small jellyfish that are much more abundant. And this was really the hardest nut to crack here from all of the fields, was how to quantify organisms, which is, it sounds pretty straightforward, but if you think of the sea, then you think in 3 dimensions, and then you get density per cubic meter or per square meter, or just the number of specimens that you've seen over a given transect. And you see that when everyone is working in different methods, it's hard, really hard to bring them together to one thing. But really opening this route towards standardization is a way forward for us. We have a manuscript coming up on this and some specific jellyfish reporting terms, because how can we proceed with jellyfish with no jellyfish stings? So yeah, we want to know if people get stung. We want to know if jellyfish are dead on the beach or still alive. And as for the second hackathon challenge, before I leave you, I'm just going to say that we want to boost the number of gold users that we have to increase the quality. We want to have quality users in the website. So we want to create something that makes it more fun and enjoyable for them than the measly little leaderboard that you see down there that we have right now. And as project lifetime increases, so does the reliability and the quality of the data, not only because you get more gold users with time, but also because you get to experience things like here, what I'm experiencing with you right now, which is standardizing the data. So once again, thank you for your attention. And if you want to join the joyride, we are here for you.
Yes. Jellyfish joyride sounds like a very tempting and kind offer, Dory. Thank you so much for the general introduction and also to concrete challenges for the hackathon. And it links very well with the other presentations. Now, I know we were stealing some time from you, Dory. I hope you can stay on to a 1:15. Because I want to give the floor also to Pedro, and then we take the questions for both of you at the end. But before we do that, can we please do a group picture? Everybody turns on their camera, and so we take a picture of all of us for memorizing this interesting moment of the hackathon. Let me see, everybody turn. How do I actually get the view? I need to get gallery, like, okay. And like this. Everybody turn on your cameras, please. We will take a group picture. Adelio, Babis, I know you. And Ching, Park, Antonios. Let's see. Smile. Okay, let one more. So the rest of the looks like there's 2 slides, 2 pages here. Let me see. I'm not very good at this. Apologies. Camera's on again. Yeah. Like this. Okay. Let's say it's done, and we are moving on to Pedro Gonzalez from TerraDua, who is going to talk about best practices in modeling and processing. What was it, Pedro? In Iliad modeling, yes.
Okay, thank you very much. Let me put this in presentation mode. Thank you very much, Bente, for the invitation. I'm Pedro Gonçalves. I'm TerraDua's director. I'm being involved with some of you, or most of you, also in several projects in the European Commission, in the European Space Agency, dealing with Earth observation, dealing with Earth science data services. And yet today I was invited to talk a little bit about Iliad applications, Iliad models, and what are the best practices that we are following, what we are using, and how do we making full advantage of them in the concept of a digital twin. So Iliad applications and models, we reduce to them in the end, they are in fact just a set of command lines tools with numerical, textual data parameters that are organized in a computational workflow. I know it's really reductive, but we take it like this, we assume it. And what we use is an application package, a text document that is able to describe the full and to grasp the full complexity of the simplistic view of applications and models, and try to define what are the inputs and the outputs of all this code, and how they are orchestrated, and how do we have how the data flow behaves in that complex flow of different process. The idea that we are following here is that an application package in Iliad, in a digital twin, should be able to guarantee the automation, the scalability, reusability, portability of the application, while also being really important point here, workflow engine and vendor neutral. So in the sense of cloud agnostic, it's not because you've run it once into one type of platform, they're not able to run it somewhere else. And so thinking about all this, we come to the application package. The application package is something that we developed and wrote a best practice in the OGC a few years back. It was focusing more in terms of Earth observation application packages. And what we've been working here in work package 5 is really transforming and adapting and see how can we really reuse this and taking in consideration an application that can be complex, simple, could be a Python script, can be a set of shell scripts, can be a more complex application. But how do we containerize into one or into multiple elements? How do we register it? And how we are able to define all the inputs and outputs using the common workflow language, and then how do we execute into platforms? How we are able to say, execute me this code with these parameters into this platform, into a given, and so deploy it without being locked in. So even resources that can be your own private resource or your own cluster, private one, or a commercial cloud, or an institution that is providing resources to the project. What is the application package? Is really using a definition, a best practice in how to use the common workflow language. Common workflow language is an open standard for describing analysis workflows, in terms of being portable, scalable, and in different environments, so workstations to cluster or HPC. And we try to define what are all the parameters using this CWL. We need to containerize it, to register it, and then to really use it. The common workflow language initially, a few years back, really started more in the domain of bioinformatics, medical imaging, astronomy, physics, and chemistry. We started using it in Earth observation a few years back with quite a good approach, and trying now to use it also how to package all the models in Iliad and how to be making them really portable. And here is the point that is really important for us when dealing with this, is not developing a model to run into a specific infrastructure, but really trying to see how can you adapt it and how can you package in such a way that you can use these different types of what we call execution scenarios. So in sense of being local clusters or HPC. I'll do just a quick overview here. What you asked me to in this is just really a simple best practice, and then there is documentation. There's going to be also in terms of training or more examples. But it's basically you define what is your service, you define what are your parameters, you define what are your input in a command workflow, and then here you can give it more complex. Then you can say what are the types of inputs, what are the type of outputs, what type of requirements that you give. So it's quite open. And you can say that one parameter can be multiplied into different nodes. You can then I'm not going to drill down in all of this, but just to show you the potential. You can have different containers, and you can say, oh, spawn one container into multiple elements, or this container needs to use GPU because it needs this type of resources, or then you can also say in terms of memory. So you can really be specifying your algorithm that exists, but what we do as work is the application package. And since how do I describe a model that is already developed? And sometimes this is a reverse engineering, because we have laboratories that have been developing a type of model that have used it and deployed it in their own infrastructure. And from there, we see that, okay, application A needs to run first, then the second one, this needs a better cluster, this needs the different type of resources. And the type of code that we use is we have the liberty to use containers, but you can also use Python code embedded there, so to work and to help you out in all this application package that you are defining. In terms of requirements, you can say, okay, use this type of container with a specific requirements, or use this type of parameter and this type of flow. Oops. Oh yeah. And then you have things that you can define steps when they are parallelized, and you can say that I want to execute a function inside of a container that is dealing a particular aspect of my model, or also to do the parallelization in a given way. In terms of data management, what we are dealing here is the most complex, one of the complex issues that you have when you're doing applications and doing workflows. We are really adopting the spatial temporal asset stack catalog definition to really describe what are the inputs of a given model and what are the outputs. So as an input to an application, into this application package, what we have is stack collections, the stack items that given as inputs. And then after the application is processed, the models have become, now they have the need to define and to give better metadata to their results. And we are using stack also here to say what are let's say one of the mandatory things here that we have is that, okay, you produce a result, you need to give some minimum metadata about it, so that is able to be caught out by a next step of workflow, or even caught out by a different storage and catalog entry. And so we are using a stack and stack assets to really define also the stage out of the different models. Then in the a big work that we've been doing in Iliad is all these models, all these small functions to be able to be registry. There's a registry and they're able to be findable. And so you have different type of models for different types of regions with different type of parameters. All these packages are being made available in Iliad, specifically in the website below by in Estec. The Iliad registry, that is a catalog of applications, of models that are available in Iliad Digital Twin. So you are able to really register tools or register workflows and find access. So, and tools here are really in the sense they are already application packages. So it's something that you can take them out and deploy and use, or your own cluster, or as a service in some other platform. And I know my time is out, so I see you, Bente. So I tried to do quickly, but there is more information and documentation in overall project about this. It was just an overview of the potential that we are working with. Sorry, Bente.
No need to be sorry. Thank you very much, Pedro. This is very useful. I find myself having followed it. I have one comment, and we will let now people ask questions. So prepare your questions for Pedro and for Dory, by the way. But I mean, this application packages, you showed it came originally from ODC, but then we in Iliad adapted it and further developed it. But it's as a part of the ocean activity, but it seems like it can be used to combine different thematics. It's not limited to ocean, is it?
In reality, yeah, it's true. It's a very good question. In reality, it came from bioinformatics, not even from the OGC bioinformatics world, the community. It was a grassroots of people dealing with large amounts of data with different compute, and they had different computing execution scenarios in mind. So we first, a few years back, 4 or 5 years, we see, okay, how can we use this in terms of Earth observation applications? Here in Iliad, the work was really, okay, can we really reuse it to models? Because sometimes, oh, it's a different beast, the model. You can't reuse it. And we are doing is this type of thing. With NSTech in Work Package 5 is really working on that. So it's the same. We are not changing. We are detecting a few points that we might do a version 1.1 of the best practice inside of the OGC. So feedback the process so that we evolve that best practice. It was more a matter of time yet that we didn't do this type of things, but it's not limited to the ocean. Yeah. It's not to answer your question directly. Yeah.
Yeah, that's good, because as I said, our approach to digital twins of the ocean is actually encompassing human activity, and the items, the boat or a wind turbine or whatever is in the ocean, which is not an ocean itself. So it's
it's completely good point.
Yeah. Okay, thank you, Pedro. Let me see. Can you unshare your screen, perhaps, unless you have a contact information? No, it's fine.
Okay.
Yeah. Okay, let me see. Do I see any hand raised? Do I have a question here? A question for Dory and for Pedro. I don't see any. No, it was. Dory, did you have any additional comments, perhaps? And that goes for all of you, by the way, since I don't see any more questions. Dory, you're muted in case you are trying to speak.
Sorry.
Yes.
So in relation to the big players in the field, and I'm not talking about NVIDIA and Google right now, I'm talking about eModNet and GBIF and the larger repositories of data. I know that they're all working in some collaboration together, and that there are some fields that are shared. Now, what I really wanted to do is anyone sitting and looking to the upper levels of all the large repositories, or is it all happening on our level, between the projects and the organizations?
Oh, in this hackathon, you mean, Dory?
No, I'm talking about in general. It's a question for Valeria, actually.
Oh, yeah, for Valeria. Okay, yes, yeah. Valeria.
Yeah, thank you for the question. And I would say it's happening on both levels simultaneously, because of course, regarding the perimeters of data collections and data storage, based on the more pure technology side, it is happening on a higher level, but it is happening under the guidance, let's say, of international entities. For European, it would be directly the European Commission. It would be entities deriving from the European Commission. For example, CINEA is doing a lot of work, and many other different entities like that. So yes, it is happening on a technological side on a higher level under the guidance of international entities, and on, let's say, a lower level, but not lower in quality, it is happening between projects. So between programs and projects, because first of all, I believe because many of the entities, let's say research centers, universities, companies like mine, happen to work on different projects together. So if they already know each other, they can put in practice what they have learned and what they have set in previous and different projects. So that is something that is spreading. So that's happening. But another thing that is happening, I believe, is that the different guidelines, let's say the Inspire guidelines, the FAIR guidelines, and all the metadata guidelines that we are repeating almost like a broken record, are getting into the DNA of the data collection and the data management. So talking about it in workshops, in hackathons, in events like this one, happen to get even more spread, I would say. So in conclusion, yeah, I would say it's happening on both levels simultaneously.
Thank you.
Thank you. By the way, for this hackathon, I believe EMODnet will provide us with a hackathon package in addition to what Valeria described today and presented today. So there will be more information. And I just put in the chat now, the last one is the Twin Lab, where we plan to have all the teams in the hackathon will get their, you can use the Twin Lab and to create their own workspace on the Twin Lab. And of course, those things that are already available on our marketplace will be made available in the, so what we will set up a special page dedicated to the hackathon, so it will be easier for you to find the different resources. So for instance, a recording of today, of the presentations you heard, plus other material that we will make available. So it will be, we will try to facilitate easy access for all the participants. And there were, and I also want to remind, I look at the time, we are 1 minute after our deadline now. I just want to remind you that there's another webinar tomorrow already on generative AI, and with some good examples from the industry related to twins, of course, digital twins. And later in June, at least, we have already policy. So when you are developing a digital twin of the ocean, there's numbers of policies you have to relate to, plus Twins itself can also provide valuable information and input to new policies and updating policies. So there will be a dedicated webinar on policies. That will be in the end, so 25th or 27th. You need to subscribe and to follow us in social media, etc., to find that. Unless, of course, you are already registered for this hackathon. If you have other ideas, something that you feel that we could provide of training, either from Iliad ourselves or from our community around us. Today we had EMODnet, and we have many other of the ecosystems in our Iliad community as well. So you can just make a wish, and I'm pretty sure we will be able to come up with some good webinars, educational webinars now in the beginning. I don't know if there are, yeah, there is one more, by the way, there is one more webinar I want to alert you about, and that is on the 12th of June, where we have the Iliad webinar series, and that will be on blue economy. So I think this is something you should put back of your head as well, that back of your ear, or whatever you say. It will be an interesting webinar for this hackathon as well. So we will provide more information, of course, in emails, etc. But I just wanted to inform you who are here now. And with that, unless there is something else, Pauline, do you have any final closing words that you want to say?
Sorry, no, I'm really pleased to see so many attending, and you know, very pleased to be able to give this webinar. Jay is also here, and he leads the team for best practices and standards in Iliad.
Yes.
I don't know, Jay, if you want to say the final sentence? No. So thank you all, and I hope you've gained some knowledge. Thank you.
Yes. Okay. Thank you all. Thank you all speakers.
Thank you,
Thank for all the attendees. See you very soon, I hope.
Thank you. Bye.